This video will show you how to perform nonlinear regression or how to estimate nonlinear function in Excel. One of the assumptions for regression model, or one of the assumptions for the application of ordinary least square method, which is used to estimate parameters of linear function, is that parameters should be linear, or the function should be linear in parameters. But there is a way how to estimate also nonlinear functions in Excel. So this is example where we will investigate relationship between advertising cost and revenue, and we expect that advertising cost will be independent variable and will influence revenue. Revenue will be dependent variable. As you can see from this picture, on this X are advertising costs, and here is the revenue. And you can see clearly pattern in this figure. If we will apply linear function, I will try to add linear function. So add linear, display also R square and equation in chart. This would be linear function estimated. So we could do the same in Excel using ordinary least square method. Once again, if you would like to estimate regression parameters, select data, go to data analysis. Data analysis and select regression. The range of dependent variable will be range of revenue, range of independent variable will be advertising cost. I selected also labels, so I will check on labels. I will select output range because I want to have all the regression outputs in one sheet. So I will select output range, and that's it. That's all we need. So it's not necessary to check any additional outputs. Click OK, and this is linear regression. So actually you can see this linear function in this regression output. So what you should know in this output: multiplier 0.91 means strong correlation between these two variables, strong relationship R square. Linear function describes or explains 84% of variability of revenues. Revenue is dependent variable, so this function explains 83% of variability of revenue, which is not bad. Function is significant, or estimated model is significant. Significance f is smaller than 0.05. Also, estimated regression coefficients are significant. P-value, both p-values are smaller than 0.05. And here is the estimated function. Estimated regression coefficient, intercept 32, and advertising cost coefficient 14.6. So actually we estimated function advertising costs are equal 32.5 plus 14.6 advertising cost plus some random error. So that's estimated linear function. Actually, this regression coefficient could be explained as intercept. In case of intercept, it's the average value of revenue in case when advertising cost will be equal to 0. And in case of 14.6, which is regression coefficient estimated for advertising cost, if advertising cost will increase by 1 unit, then revenue will increase because there is plus sign. Our average increase of revenues will be 14.6. So once again, if advertising costs will increase by 1 unit, average increase of revenue of revenues will be 14.6, which means we have just sample data, sample evidence. In some case, the increase could be higher. In some case, increase can be smaller, but average increase will be 14.6. If you look at linear function in this chart, you can obviously see that real observations have a little bit different shape than linear function. So if you would like to calculate revenues based on advertising cost, actual predicted values will be on this linear function, which means, for example, in case of advertising cost equal to 6, here would be predicted revenue. Advertising cost equal to 4, predicted revenue will be at this level. And linear functions suggest also that with decreasing advertising costs will decrease also revenues. So for example, if advertising costs will be equal to 2, expected revenues would be somewhere over linear function over here. And also in case of linear function, if advertising costs would be equal to 10 or more, it will expect linear increase in revenue. And you can see that the true revenue, real values, behave a little bit differently. Decrease in this part, it decreased more than it's expected, and with increasing advertising cost at this level, revenues are increasing much more slowly than linear function. So it could happen that linear function would not be the best one for the forecasting of revenues. And another thing, real values have a little bit non-linear shape, so maybe some non-linear function would be better for this example. So we'll try to estimate also some non-linear functions, and we'll try to compare it with this linear function and select the best one. So according to R-square value, 83% is not bad, and also linear function was significant and could be used to describe this relationship, but maybe there would be function which describes it much more better. So we will continue with polynomial function. Polynomial functional form look like this. Revenue will be equal to b sub 0 plus b sub 1 x plus b sub 2 x squared. In this case, x will be still revenues. X will be still advertising cost. Dependent variable will be revenue. We are talking still about relationship between two variables, but in this case, the right side of this equation includes x and also x squared. If you would like to estimate regression in Excel, it works the way that you should every time select dependent variable, and in range of independent variable should be selected all variables which are on the right side, or everything which is on the right side. We will select observations for x and x squared, and once again Excel will use ordinary least square method and calculate b sub 0, b sub 1 and b sub 2 regression coefficients. So what to do and how to estimate these coefficients. We already have advertising cost x values, but we need also x squared values, and we need to select it at once into Excel. So every time when you select independent variables into X range, there should be one field. So advertising costs x and x squared values will be advertising costs squared. So if you look into this function, we have everything which is on the left side, we have revenues. We have everything which is on the right side, we have advertising costs and advertising costs squared, which means we can estimate this functional form. So once again, open data analysis regression. Revenues will be the same, so revenues are already selected, and we will select advertising costs and advertising costs squared into one range. So it has to be selected at once. Select place for output range. We will use this one and estimate regression. Okay, regression output will override data, never mind. Everything's fine. You know, regression output have still the same meaning. So multiplier in this case, once again, strong relationship between these two variables. In this first case it was linear relationship, in this case it's polynomial relationship, still strong correlation. Ask where this functional form explains 95% of variability of revenues. So R square measures goodness of fit, which means compared to linear function, this function fits better the real values. This one explains 95%, this one linear function explained only 84%. If you compare linear function with polynomial function, I will add one more trend line. So I will add polynomial function order of 2, display equation R square. Here is the equation of polynomial function, and you can see that polynomial function fits better the real values. If I will remove linear function, you can see that it's much more closer to real values than it was in case of linear function. Okay, we'll continue. Once again, function significant explains significant proportion of variability. Estimated regression coefficients are significant and coefficients values are here. So actually we estimated polynomial function in form dependent variable is equal to minus 65.7 plus 49.7 advertising costs multiplied by x minus 2.83 x squared plus some kind of random error to make it correct from a theoretical point of view. So here it is. That's the estimated regression function. So if you would like to predict revenues using this polynomial function, you could fill in here advertising cost value for x and advertising cost value squared for x squared, and you would get prediction of revenues, which should be much more closer to reality than prediction in case of linear function. One more thing, how to explain this estimated regression parameters. Explanation of regression parameters depends on functional form, and actually it depends on mathematical meaning of estimated parameters in function. In case of linear function, it was quite easy. If independent variable will be equal to 0, dependent variable will be equal to intercept value. If independent value will increase by 1 unit, dependent variable will increase by value of regression coefficient. In case of polynomial function, it's a little bit different. We can say that if x value will be equal to 0, if advertising cost will be equal to 0, it means this part will be equal to 0, also this part will be equal to 0, and dependent variable will be equal to minus 65. So once again we can say If independent variable will be equal to 0, dependent variable or average value of dependent variable will be equal to intercept. It works also in case of polynomial function, but one more thing, it's not possible to have negative revenues. So I almost forget to mention that intercept value sometimes doesn't have logical explanation. So sometimes if there is nonsense, for example negative revenue or negative value when there is not possible negative value for dependent variable, in such case we say that intercept doesn't have logical meaning and we do not interpret intercept value. What about explanatory variable? In this case it doesn't work the way if advertising costs will increase by 1 unit and revenues will increase by some constant value. Why? Because it doesn't work this way in polynomial function. Actually, if you will change revenues, if you will change advertising cost, the change in revenue will depend on the place on the function where you are actually. If advertising costs will change from 8 to 9, you will move from this place in the function to the right, and change in revenue will be very small. But if revenue will change from 5, if advertising costs will change from 5 to 6, the change in revenues will be much more higher. So in polynomial function, the change in dependent variable is not constant. It could be calculated if you would derivate this function and put their value of advertising cost, but it's a little bit more complicated, so we'll not do that. You can find the information about this in PowerPoint presentation about functional forms. So remember only one thing, in polynomial function doesn't work the way if x will increase by 1, dependent variable will increase by some constant, because it's not true. It doesn't work for polynomial function. So you should know how to estimate polynomial function, how to explain regression output, how to write down estimated function, but it's not necessary to explain these estimated parameters. It's important only in case of linear function. We will move to reciprocal function or hyperbolic function. It's much more easier to pronounce. Hyperbolic function. Once again, it works the same way. If you would like to estimate nonlinear function, you should select everything which is in this function. So once again, the same dependent variable and independent variable. On the right side there is only 1 divided by x. So we should select independent variable 1 divided by x into Excel. Before we will proceed, it's necessary to create such variable. So we will create 1 divided by x column, which will be 1 divided by advertising cost. Pull it down. Now we have values of independent variable and we can select it into Excel. Once again, open data, data analysis, regression. Range of dependent variable, once again, revenues, still the same. Range of independent variable, in this case on the right side there is only 1 divided by x. Select only one column, 1 divided by advertising cost. We will select different output range, for example here. Okay, and here it is. So that's summary output for hyperbolic function, reciprocal or hyperbolic. Once again, strong relationship, very strong correlation. R-square value 96, almost 97, which means this function explains 97% of revenue. If we compare it with previous function, so R-square measures goodness of fit, this function fits the best. Why? Because R-square is the highest, higher than polynomial function, higher than R-square in linear function. this function explains behavior of revenue the best. Function is significant because significance f is smaller than 0.05. P-values, both p-values are smaller than 0.05. Regression coefficients are significant, and these are estimated regression coefficients. So if you would like to fill in estimated values into estimated function, dependent variable is equal to 205.9 minus 459 1 divided by x plus some ut, which denotes random error. So that's estimated hyperbolic function. Be careful about explanation. Once again, explanation depends on mathematical meaning of these values. An estimated function, in this case, it doesn't work the way if x will be equal to 0, because it's not possible to to have 0 value. So in this case, even intercept cannot be explained this way, and also you cannot say if x will increase by 1 unit, then a dependent variable will change by this value or value of regression coefficient. And I forget the decimal place. Okay, you cannot interpret it that way. But once again, the slope of this function would be different in each point. So if you would like to calculate marginal change, what will be the influence of change in advertising cost on revenue, then you should derivate this function, put the x value into derivation, and then you would get marginal change of revenues. I'm sorry. Okay, almost done. Last function. This is clearly nonlinear function, but it's used very often in econometrics and in economics, because that's the form of production functions. So usually you have explanatory variables like labor or capital, or some production factors, and dependent variable is production or output. And if you would like to estimate parameters of production function, you can see this function is not linear in parameters, but we can linearize this function using logarithms. So if you put this function into logarithms, you would get logarithm of dependent variable is equal to logarithm of b sub 0 plus b sub 1 logarithm of x plus random error should be there every time when when we are talking about stochastical econometric model. This kind of function is linear in parameters, which means we can estimate it using Excel using ordinary least squares. Of course, it would be possible to estimate also nonlinear function, but in such case it would be necessary to use different method, not ordinary least square. So if you can use only Excel, and if you would like to estimate nonlinear function, first it's necessary to make it linear using logarithms. And we will estimate parameters of this function. Once again, it will be necessary to select variables which are in this function on the left side and right side. You can see there is logarithm of dependent variable and logarithm of independent variable, which mean that we need to create first logarithm of dependent variable, then logarithm of independent variable, I'm sorry, and we will use ln natural logarithm for dependent. We can pull it also to independent and to the rest. Now we have logarithm dependent and independent variable, and we can use data and data analysis to estimate regression parameters. So input dependent variable range in this case on the left side is only logarithm of dependent variable. Range of independent variable will be logarithm of independent variable because that's the only thing which is on the right side in this function, only variable on the right side. I will select different output range. Okay, and that's it, regression output with summary statistics. So multiple are, once again, correlation coefficient, strong correlation, R square. This function explains 84% of variability of revenues. Function is significant, estimated coefficients, and p-values. Both p-values are smaller than 0.05, smaller because there is e and minus 10, e minus 6, which means 2.6 multiplied by 10 power to minus 10, which is a very small value. A very small value. An estimated function is in form, or we can fill it directly in here. So intercept value 3.2 and B1 value 0.87. And that's it. That's the function estimated in this case. What about interpretation or explanation of regression parameters in this kind of function? Is used in economics very often because this value 0.87, it's called elasticity in case when dependent and also independent variable was in form of logarithm. Estimated parameter is elasticity, and you can interpret it in percent. So it will mean if x will increase by 1%, dependent variable will increase by 0.87%. So remember, this works only in case when both variables are in form of logarithm. If there would be only one variable in form of logarithm, it would be a little bit more difficult. And intercept value, maybe you remember that intercept 3.22 was ln b sub 0 originally. So if you would like to get b sub 0 value, then you should remove logarithm of use exponential function exponent for 3.22, and you will get b sub 0. So actually, if you would like to write down this estimated function, so it would be b sub 0 25.03, and you can put here 0.87. So this would be the estimated production function for these two variables. I hope you understand the principle how to estimate nonlinear functions in Excel. So every time use data analysis regression and select only variables which are included into function you would like to estimate. And the best function could be selected using R square, or to make it even more correct, you could use adjusted R square in case one functions have different number of explanatory variables. So from this function, functions estimated in this video, the one with highest R square was hyperbolic function. So if you would like to prognose it, to calculate revenues or to predict revenues, you should use hyperbolic function to describe this relationship.